Welcome to Ask and Learn.
So for this problem, we're given the mass of copper. I have written on the left the density and the conductivity of copper, because we'll need both of those in our calculations. And we have the resistance that we want the wire to be. So the first thing we need to do is find out the volume that corresponds to 1 gram of copper. So we know that density is equal to mass over volume. And so volume is equal to mass over density, which in this case is 1.1 times 10 to the negative 7 meters cubed. So next, we're going to write out a system of equations that both involve the length and the area of the wire that we want, and they're going to allow us to solve for the length and the area. So the first equation is length over sigma times area is equal to 0.5 ohms. And this is the equation for resistance. We know we want the resistance to equal 0.5 ohms, so this equation must be true. And the second equation we will need is length times area is equal to the volume we solve for up above, 1.1 times 10 to the negative 7 meters cubed. And this is important because we know we want to use all of the copper, and so the volume of the wire has to be the volume we solve for up above. So there's a couple different ways to solve this system. One of them is multiplying the equation on the left by sigma times area, which lets you solve for L. So then L equals 0.5 ohms times the conductivity times the area. And then you plug that value for L into the equation on the right. That allows you to solve for the area. And then once you have a value for the area, you can plug that back into one of the original equations to solve for the length. So whichever way you solve that system, you find that the length is equal to 1.8 meters and the area is equal to 6.1 times 10 to the negative 8 meters squared. And so then to solve for the diameter, we just need to take area is equal to pi times the diameter over 2 squared. And if we solve that for the diameter, we find the diameter is equal to 0.28 millimeters.